Maury Pelto here, looking to examine the Sacagawea Glacier in the Wind River Range of Wyoming, both its behavior from 1966 to the present, but also looking at its future. Here you'll see the Sacagawea Glacier with the 1966 map outline in orange. In red is the 2006 profile or margin of the glacier. Just above the Sacagawea Glacier is the Upper Fremont Glacier, and we'll take a brief look at that glacier as well. So in 1966, here's a glacier flowing down from these steeper slopes toward this main terminus. So the main terminus would be right down in this particular region. Glacier ended at a small lake here. If we turn off this topographic map, we'll see the 1994 look of the glacier. Here's that small lake. You'll see another small lake has started to form right here at the end of the glacier in 1994. You'll also notice that most of the snowpack is restricted to these areas, steeper areas above 3,700 meters on the upper portion of the glacier. Lots of blue ice exposed here. And if we zoom in a little bit, you'll see that there's a lot of fern layers exposed within this, not fern layers, ice layers now. There is no really old or retained ferns. In other words, this 1994 image is showing you that this entire area of the glacier had also melted out in previous years. There had been no retained snowpack. So we have limited retained snowpack on the glacier during that period. Upper Fremont Glacier right here, you'll see the glacier is higher in elevation. This section of the glacier has good retained snowpack. Appears to have retained it each year up through this region. See some superglacial streams cutting down through. Also notice, again, we can see the margin of the glacier in 1994. Turn on the map, and you'll see that there's little change to the 1966 map for the Upper Fremont Glacier. If we go forward in time to 2006, we'll see that by 2006, so this lake has expanded. It's now 400 meters long along the margin, 150 meters wide. If we measure all these locations along this main section of the terminus, we'll get an average retreat of 350 meters. You'll see this northern section of the glacier is separated by bare terrain from the main portion of the glacier. This little part nestled beneath Helen Peak is just about to be separated. You'll see limited snow cover being retained even on the steeper slopes. This is not at the end of the melt season. There will be more melt, and basically this entire glacier, this entire section already is blue ice. You can also see some rocks outcropping amidst the glacier, even near the upper sections of the glacier. So that's not a good sign. So 35% of this glacier has disappeared. If we look up toward Upper Fremont Glacier, still that same area of retained snowpack. It's not a huge area, not enough to sustain this whole glacier, but it seems to have a consistent area of accumulation on this glacier, which has helped it maintain nearly its same size. If we zoom in again a little bit on the Sacagawea Glacier, we can see a lot of annual horizons. Here's a really dirty annual horizon here, so dust accumulates on the surface of the snow. It would then get buried, turned into ice, and then it kind of re-emerges at the surface. So this marks a particular year with considerable accumulation of dust on the surface of the glacier. And if you sampled that, you can figure out where it came from and maybe even its timing. But again, we'll take a look in at these, what should be the accumulation zone. Again, you can see blue ice, blue ice. It's indicating that this, not just in 2006, but 2005, 4, 3, 2, none of those years was there retained accumulation in these regions. So even the upper portion of the glacier is suffering. So that brings us to kind of the idea, if you're looking at if a glacier is going to survive, how are you going to diagnose this? Well, a glacier exists because accumulation of snow is greater than the melting. So this occurs not over the entire glacier, but over the glacier as a sum. So there has to be an accumulation zone, an area where snow never melts, even in the summer. So to diagnose a glacier is disappearing, look for areas where you have rock outcrops emerging in the accumulations where the accumulation zone should be, the upper region of the glacier, recession of the upper margin of the glacier, and lack of consistent snow cover at the end of the summer. So this is how we developed in 2010 this model published in the Cryosphere forecasting whether you're going to survive or not. And in terms of applying this, if your upper margin is receding, if you don't have much snow cover on the glacier, those are two of the key signs. Again, upper margin here of this glacier, outcrops of rock appearing where there didn't used to be. So those are the features we're looking for. So if we apply that level of reasoning to the Sacagawea Glacier, we can see recession in the upper margin, certainly. We can see emergence of rock outcrops in the upper section of the glacier, and definitely a lack of retained snowpack. So the Sacagawea Glacier will not survive current climate. Current climate, however, will allow the upper Fremont Glacier to survive. Future additional warming would place that glacier in jeopardy as well.